The expansion of the universe is not slowing down. That is the revelation that shook cosmology at the end of the 20th century. For decades, scientists assumed gravity would act as a cosmic brake, pulling everything back, slowing the expansion that began with the Big Bang. The question was whether gravity would be strong enough to halt the expansion entirely, perhaps even reversing it, leading to a future collapse of Big Crunch. Others imagined a delicate balance, a universe that would expand forever but at an ever-decreasing rate, gradually approaching stillness. But the universe surprised us. It always does. When astronomers measured the light from distant supernova exploding stars that can be used as cosmic mile markers, they discovered something astonishing. The expansion was not slowing down at all. It was speeding up. Galaxies were not merely drifting apart. They were being flung away from each other faster and faster, as if some mysterious force were pushing the cosmos outward with invisible hands. We call this force dark energy. The name is a placeholder, a confession of ignorance disguised as terminology. We don't know what it is. We don't know why it exists. All we know is that it makes up roughly 70% of the universe, and that it drives the accelerated expansion of space. Dark energy is not like matter, not like radiation. It does not clump or cluster. It acts uniformly everywhere, like an unseen pressure inflating the cosmos. The discovery of dark energy transformed our view of the universe. The cosmos was not merely coasting on the momentum of the Big Bang. It was accelerating into a future stranger than we had imagined. And if acceleration continues, the fate of the universe is not a gentle fading, but a relentless tearing apart. Picture this. Billions of years from now, galaxies that are now visible in our telescopes will slip beyond the cosmic horizon, carried away faster than light by the swelling fabric of space. The night sky will grow emptier. Future astronomers, if any remain, will see only their own galaxy, surrounded by darkness, cut off from the larger universe. To them, the cosmos will appear small, lonely, bounded. They will never know the truth we know today, that they live inside an endless, expanding ocean. The evidence will have vanished beyond reach. But the story may go further still. If dark energy remains constant, galaxies will recede from each other forever. Stars will exhaust their fuel, black holes will evaporate, and the universe will approach a state of heat death and eternity of cold, thin emptiness. If dark energy grows stronger, the acceleration could increase without limit, culminating in a scenario called the Big Rip. In that nightmare future, space expands so violently that galaxies are torn apart, then solar systems, then planets, then atoms themselves. The fabric of reality unravels until nothing remains. And yet, perhaps, dark energy will change. Perhaps it will weaken, fade, or even reverse. Perhaps the universe will slow, halt, and collapse back inward. Perhaps the cycle of creation and destruction will repeat endlessly big bangs, followed by big crunches, an eternal heartbeat of existence. We don't know. The future of the universe is unwritten. What we do know is this: the absence of edges does not mean the absence of endings. The universe has no boundary, but it may have a fate. And in contemplating that fate, we confront our own, because we are not separate from the cosmos. We are not spectators sitting outside reality, watching it unfold like a play. We are part of it. The atoms of your body were forged in stars that burned billions of years ago. The heat of the Big Bang still warms the universe around you, its faint afterglow detectable with instruments. The expansion of space carries you along, whether you wish it or not. You are not merely in the universe. You are the universe in one of its countless arrangements, reflecting upon itself. Think again about edges. Your life has edges. Birth and death, beginning and end. Your days are bounded by sunrise and sunset. Your breath has edges. Inhale, exhale. But the cosmos that contains you does not share those boundaries. It stretches endlessly, heedless of the limits that define your existence. To realize this is to experience a strange paradox. You are finite, yet you are woven into the infinite. You are temporary, yet you belong to something eternal. The acceleration of the universe, driven by dark energy, makes this paradox even sharper. For as the cosmos expands faster and faster, the future diverges from the past in ways almost too great to grasp. The galaxies that share our cosmic web today will be lost tomorrow. The stars that light our sky will fade. The vastness we marvel at will become emptiness. And yet, within that emptiness lies the proof of something astonishing. That existence itself is not fragile, not bounded, not limited by edges. It simply is. When you gaze into the night sky, you are looking not only at distant stars, but at distant times. Light from the Andromeda galaxy left over 2 million years ago, long before humans existed. Light from the most distant galaxies left billions of years ago, when the universe was young. To look outward is to look backward, to see time unfolded across space. And as you look deeper, you are not approaching an edge, you are approaching a beginning. Beyond the farthest galaxies lies the afterglow of the Big Bang itself, the horizon of our vision. But even that horizon is not a boundary. It is simply the limit of light's journey since time began. Beyond it lies more universe, unseen but real. This truth should humble us. It should also liberate us. For too long, humans have imagined themselves as the center, the purpose, the focus of creation. But to live in a universe with no edges is to realize that we are not the center of anything. We are not perched on a cosmic cliff, gazing outward. We are immersed, surrounded, suspended in infinity. Our importance is not given by position, but by perspective. We are significant not because the universe cares about us, but because we are the part of the universe that can care at all. So the question of dark energy, of acceleration, of ultimate fate is not merely a scientific puzzle. It is a philosophical mirror. It forces us to confront the nature of existence, of meaning, of value. If the universe will end in heat death or a big rip, does that render our lives meaningless, or does it make every moment more precious, every thought more miraculous, every breath a defiance of inevitable entropy? Perhaps the lack of edges is not a curse, but a gift. Perhaps it is a reminder that reality is not a box to be measured, but a mystery to be lived. And yet, the mystery deepens, for dark energy is not the only unseen force shaping the cosmos. Alongside it lurks dark matter, another invisible presence, making up about 25% of the universe. Unlike dark energy, which pushes, dark matter pulls. It clumps, gathers, forms scaffolding upon which galaxies are built. Without dark matter, galaxies would fly apart, unable to hold themselves together. Without dark matter, the large-scale structure of the universe would not exist. We do not see it, but we see its effects everywhere. So here is the riddle. We live in a universe where 95% of reality is invisible. Ordinary matter, the atoms that make up stars, planets, oceans, trees, people, accounts for less than 5%. The rest is hidden, mysterious, unknown. We exist in a cosmos without edges, but most of it is concealed from us. As if reality itself were teasing us with glimpses of a truth we cannot yet comprehend. Perhaps that is the ultimate meaning of an edgeless universe. It is not just a physical description of space. It is a metaphor for knowledge. There is no edge to what can be discovered, no limit to what can be asked. Every answer births new questions. Every horizon reveals another beyond. We are not chasing the end of knowledge, because knowledge has no end, just as the universe has no edge.